Day 24 about to begin. I am ready for this to be done, that is for sure. Hoping for another easy day. Here's our sample data, looks like. All right, partway up the mountain, flat, serves extraction points. A bit of a climb, nothing extra can handle. At least that would normally be true. Now that the mountain is covered in snow, things have become more difficult. Expedition reaches valley, must be traversed, reach the extraction site, strong turbulent winds, small blizzards. I think everyone packed warm clothes to make it across the valley. You need to find a way to avoid them. Fortunately, it's easy to see all of this from the entrance to the valley, so you make a map of the valley and the blizzards. Walls of the valley, everything else is ground. Clear ground is a dot. Otherwise, blizzards are drawn with the arrow indicating the direction of their motion. The above map indicates two blizzards, one moving right, one moving down. In 1 minute, each blizzard moves one position. Due to conservation of blizzard energy, as the blizzard reaches a wall of the valley, a new blizzard forms on the opposite side of the valley, moving in the same direction. After another minute, the bottom downward moving blizzard has been replaced with a new downward moving blizzard. Okay. Because blizzards are made of tiny snowflakes, they pass right through each other after another minute. So they're both there with a 2, and then they move on. Finally, after you get another minute, right word facing blizzard on the right, blah, 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 blah. Here's a more complex example. Your expedition begins in the only non-wall position on the top row. It needs to reach the only non-wall position in the bottom row. On each minute, you can move up, down, left, or right, or you can wait. You and the blizzards act simultaneously, and you cannot share a position with the blizzard. Above example, the fastest way to reach your goal requires 18 steps. Drawing the position of the expedition as E, one way to achieve this is that. Minute 1, move down. Minute 2, move down. We did not yet talk about, so there are no blizzards that are moving up, down on the dots. Interesting. Minute 3, wait. Minute 4, move up. Minute 5, move right. Minute 6, move right. Okay, so there's a bunch of minutes. It's the fewest number of minutes required to avoid the blizzards and reach the goal. And our input is very blizzardy. All right, our input is very blizzardy. Let's go ahead and throw, actually, let's not do that yet. The first thing we want to do is actually get this data in here. But the real data looks like that. So it's looks like a 100-ish by 35-ish grid. So decent sized. Okay. If everybody's going to move, you can't stand still when a blizzard is coming down on you. So not every move is going to be legal. But this feels very much like the problem a few days ago where we have 5 choices and we have to evaluate all 5 choices, right? And see what happens. Put them on the queue and then try them out. There were some shortcuts in that before that we ended up with related to, yeah, is it just fixed? Yeah, okay, so the position is fixed. Yeah, there were some shortcuts related to, those were resource collections. So there were some resource collection shortcuts that we could take, that we could look to see about duplicating, trying not to duplicate things. So I think that is probably the thing we're going to have to do is duplicate, right? Deduplicate so that we can make sure that we can do everything in a reasonable amount of time. Okay, so we're going to say the board is this. So the board is going to be, let's see. Actually, do we need, I mean, we need to record everything that's there for sure. Right. Okay. So let's do this then. The board is going to be a hash set of, let's see, a hash set of, I think, X, Y, and then direction. All right. So these are actually going to be the blizzards. So y is 1, y is less than data sub 1 dot length or data dot length minus 1 double plus y. And then x is 1, x is less than data y length minus 1, because we're just going to ignore the walls. We're going to say if data of y of x is not equal to a dot, then we're going to put you in the blizzard. Actually, the blizzards can be a character. That's fine, right? Then we're going to say blizzards add x, y, and data y, x. And so the start is going to be 1, 0, right? It'll be x and y, 1, 0. End is going to be x is data 0, length minus 2, right? Because we want to be in 1, 2, 3, 4, 5, 6. We want to be in 6. And this length is going to be 8 long, right? So we want to be in 6. And then y is going to be data length minus 1. All right, so for this, we're going to say party. Party is going to be in the start, right? And we're going to have I think what we do here is, so we need a copy of the blizzards for every proposal, right? Because we're going to have an expedition place, and then we're going to have the current blizzards that are going on, right? So our to run then will be a stack. I don't think it really matters. A stack of x, int x, int y, party, and then hash set of int x, int y, char direction blizzards. All right. And then to run, we're going to push the party and blizzards to hash set, which will get us a copy. While to run count is not equal to 0, we're going to go find all of those. And we need to, our result is steps taken. Also, I think that means we need to record the steps taken. Yeah, well, we need to, every time we have one that finishes, we need to record it, right? So we'll say the best is going to be long max value. That's what we need. We are going to return the best. And we need to know what step we're on, which I guess means this is step, which means we've taken 0 steps to begin with. Okay, so what we need to do then is we need to move all the blizzards, right? So current is going to be to run pop. We need to move the blizzards. So for each var blizzard in current blizzards. All right, and then we say new blizzards. It's going to be a new hash set. All right. And we'll move all the blizzards. So we want, let's do this. Min blizzard x is 1. Max blizzard x is this. It's actually -2, right? And then min blizzard y is 1. And max blizzard y is this, except -2 and not -1. So you could say now you can say less than or equal to the max blizzard y and the min blizzard y, the min blizzard x, less than or equal to the max blizzard x. Okay. We need to do a movement. So we need to do if blizzard direction is this, else all of this. All right, so we've got this, we've got this, we've got this, and we've got that. All right, so if you're moving left, then we're going to say blizzard x double minus, no, that's y, yeah, no, that's right. If double minus blizzard x is less than min blizzard x, then blizzard x becomes, oh, you're not going to let me change it, right? Because it's not mutable. Yeah, that's fine. New blizzard. Let's see, we'll just say var, let's see, new blizzard is a blizzard. Make a copy. All right. Then you get to go Bmax. And when you go down, this is double plus on y, which means if you're greater than y, then the y gets to be, if you're greater than max blizzard y, you go back to min blizzard y. All right, and then this is right, which is x's. So x's, this will be max and min. And then this is up, so that'll be double minus. This is greater than, this is less than the min, then you get to be the max. Okay, so that's each new blizzard. We say new blizzards add, new blizzard, actually just add the new blizzard. Right. So once all the blizzards have moved, then we need to propose our moves. We could stay in place. We can only stay in place if we're not at the start, right? So staying in place would be we can actually only stay in place if there's not a blizzard, right? So if we're not at the start and new blizzards, I think I want this to be a no. Yeah, I was thinking I wanted this to be a dictionary. Because then it would make the contains easier. But it means I have to, it's okay. Yeah, that's okay. Except it can't be just a char, it needs to be a list of char. All right. So you're going to be add an XY and then a new list of char with this guy in it. And this is our blizzards. We know that every blizzard, every position could have multiple moves. So that's all we have to do, right? To dictionary. Yeah, blizzards. Okay. That's our dictionary. What's the problem? Dictionary, okay. There's no zeroth to dictionary. From a dictionary, you can't just make a copy. You have to do this. Okay, fine. So this is going to be a blizzard list. All right, then we're going to say for each var direction and blizzard list value. And we're going to say if not new blizzards. No, we'll do that down here. All right, so the new blizzard is the blizzard list. No. New, this is going to be new location is going to be the blizzard list key, right? And then this is the direction already. It's a little aggressive. Okay, and then we say if not new blizzards contains the new location. And we're going to say new blizzards add a new location and a new list of char with the direction in it. Otherwise, new blizzards, well, we can do a try get, right? We'll do this like this. Try get value, new location, out var direction list. Then we can say direction list add our direction into the direction list. Otherwise, what is the problem? Can it convert XY, new blizzards? Oh yeah, new blizzards is the wrong type. Okay, so that's that. And so new blizzards contains key for current party. Then we are going to push onto the list to run push. Let's see, current step +1, and the party is going to stay put, and then the new blizzards. All right. And then we're going to say actually, we don't even need to do that. We'll do it like this. Try push, yeah, whatever, try push. Then we're going to try push current step +1, party X -1, party Y, new blizzards. All right, so then we'll go left, we'll go right, we'll go up, we'll go down. Those are all of those. Go ahead and generate that method. You're going to need the stack as well. So you're the to run. V is step. This is the party. And these are the blizzards. So if X, so first of all, if party X is greater than, let's see. So if party X is less than max min blizz X, we're going to return a Boolean here. Actually, let's do this. So if party is the end, we're going to return true. That means we bail. So we're going to say if you were able to push, then best is equal to math min best, and actually current step plus 1, right? These need to have the to-run stack. Try, finish, or push. Okay, so if the party made it to the end, then you're good. You can stop. Otherwise, if the party is outside the bounds, party X is greater than max BlizzX, or party Y less than max blizz or min blizz Y, or party Y greater than max blizz Y, then we're not going to add you. Y int X and int Y. We missed that. I don't know how. It's fine. Otherwise, we're going to push you on the list, right? So to run, no. The other thing we need to check is if the blizzards contains the location of the party, then we can't do it either. Otherwise, to run push step party blizzards. Okay. Try, finish, push. And we're also going to return false here because we're not done. False indicates whether we're done. Okay. So then this needs to be here every time, right? The problem is this can't be just party. Actually, it can. All right, we're just counting steps. That's fine. We don't actually care where the party ended up. So why are you guys upset? Name try push. Oh yeah, try finish or push. I actually don't need this because the fact that you're outside the bounds will tell me you're not allowed to stay anyway. So that's okay. I think that's it. I honestly think that's it. We haven't done any caching yet. So to do caching, which actually comes up here. But on the small board, we should be able to finish up pretty quick. That is a giant number. That looks like long max value. So I want to record every time we finish. It looks like we didn't finish, which is fine, I guess. Actually, it's easier to just set the breakpoint here. Do we ever finish? We don't ever finish, we think. Find that very strange. Let's do this then. Let's say print the board with the blizzards. The blizzards in the party. Wait a minute, am I using party and I should be using current party? Is that what the problem is? Yeah, that's totally what the problem is. So party needs to go away, right? And then when we push this, we're going to just push the start. Well, this is undoubtedly a big part of our problem because we never actually moved the party because we were using the party. Did I say the word party? I think I might have said the word party once or twice. Okay. Yeah, so we need the cache. We're definitely going to be in a situation where everything is pretty much the same. So the problem with the cache is now that we're using a dictionary and not a hash table is that I can't. I mean, I can make the cache as a hash table. And we're going to need on all these, we're going to need visited. Do I need it here or can I put it up there? Because I think if I put it up there, that'll be easier. So you're going to be a hash set of party X, party Y, and then all the blizzards. Yeah, that's kind of a bummer, right? Movement cache. So let's try record struct movement cache, and then you will be, you know what? I think I'm going to need a class here, aren't I? And I'm going to need because you are going to be a party, right? So int x, int y, party, and then also the dictionary of blizzards. So the dictionary of blizzards. Yeah. So I'm going to want to record the party. I'm going to want to record the blizzards. No. I'm going to want to record the blizzards. And then my implementation of equatable equals, but also get hash code. So we're going to return hash code combine the party, and then blizzard select many. Don't know if I just throw a list into the hash code combine, what it's going to do with that. Might be bad. Hash code is a new hash code. Hash code add party for each blizzard list in blizzards. We're going to say actually I want to transform this here. All right, I want to transform this here. This is where I want to do all the link, the ugly link. I need to select many out of the KVP. I want to get, I think, no, select. P key, so that's already that. So I want KVP key X, KVP key Y. Yeah. Yeah. I think you need to be a select many, at which point you are an IEnumerable. Yeah. To list, right? You can be direction. All right, so for each blizzard in the blizzards, hash code add blizzard, turn the hash code to hash code. All right, and then here, if not other is movement cache, other cache, return false, then we're going to return that's what I meant. Then we're going to return parties equal to other cache party, and blizzards. If I make this a hash set instead of a list, then the equality will be this. That should do that. All right. So here we're going to say if visited, let's see, we need to make the movement cache, right? New movement cache for the party and the blizzards, current party, current blizzards. If visited contains movement cache, continue, so stop analyzing if we've already analyzed this. Is that going to help us? That does not seem to be helping us. So let's do evaluated is going to be 0 long. Call if, let's see, if evaluated mod 1,000, let's do 100,000 equal to 0, then we're going to say console write line Evaluated, and the movement. We didn't put anything in the movement cache. The visited count. That's why we didn't save any time. But hey, that's why you learn here, right? Visited, add movement cache. So we evaluated 100,000 options and not eliminated any. I don't buy it. I wonder if this works. Let's try. Hash one is a new hash set of int char 1 2 a 3 3 4 b, right? And put that in hash 2. Console right line hash 1 equals hash 2. False. Okay, so that didn't work. So that's why we're not caching anything. There's got to be like a hash set, right? There's got to be like an equals. Is it something other than equals? Guess not. So we have this, and then we have this, which is going to be blizzards count is equal to other cache blizzards count. And then we're going to have blizzards all other cache blizzards contains that blizzard. All right, you want to simplify? Go ahead, simplify. Okay. That fix us? We've got 0. I don't buy 0, that's for sure. Okay, so we never found anybody. I guess we're going to have to walk through these one at a time and see what happens here. Oh, duh. It's fine. It's fine. If you stop running the code, it stops running the code. Yep. 29. Is 29 the answer? No, the answer is 18. Minute 1. Let's make sure that I've got the rules right. Walls of the valley are drawn as blah, everything else is ground. All right, you want to try it with this. And then we can at least try understanding what our options are. Okay, so we're going to do this, right? So current party at 1 with 2 blizzards. 1 to the right, 1 down. Okay. So our new proposals should be to the right would be 2, 2, and down would be 4, 5, right? So the new location to the right is going to be 2, 2. So that goes into the blizzards list. And then our next one is we're going to go from 4, 4 to 4, 5, right? Okay. So that goes in the blizzards list. Then we're done, right? So here, party's not at the end, obviously. Party's outside the bounds because we can't just stand still, so that's fine. And then here, right, the party would be 0, 0, so that's outside the bounds. Party is 2, 0, so that's outside the bounds. Party is 1, negative 1, so that's outside the bounds. So the party is 1, 1. Blizzards don't contain any 1, 1s, so that should be okay. So we got the step and the party and the blizzards. And the blizzards are 1, 2, and 4, 5. Those are the wrong blizzards. No, wait a minute. New blizzards, new location, direction list. What did I miss here? You're fine. So your blizzard to the right should be 2, 2, and 4, 5. 2, 2, and 4, 5, right? Two, 2, and 4, 5. So then we come up here. These blizzards, why do they say 1, 2, and 4, 4? Why? New blizzards. We make a new dictionary every time. Put new location in it. We put new location in it. And we're passing new blizzards here, new blizzards, new blizzards, new blizzards, new blizzards. What the hell? Why are the blizzards not moving? Fine, go to there. New blizzards. 2, 2, and 4, 5. So when I F11 in here, that blizzards are those blizzards, right? Why do they say 1, 2, and 4, 4? I really don't understand. Yeah, I don't get it. What the hell is going on here? Why? Why? What the hell am I missing? I mean, that's the right thing. I mean, I'm willing to get rid of the step plus ones everywhere. Actually, I can get rid of the step plus ones everywhere. Oh, no, I can't. It's fine. See, current step, current party, new blizzards. I don't get it. I'm confused. What the hell is going on here? Two, 2, 4, 5. 1, 2, 4, 4. It's not this, is it? I mean, that couldn't be it, right? Nope. There's some kind of naming conflict. What a weird thing. And now it says 46, which is also, there's no way it takes 46 to move through that thing. There's no way it takes 46 to move through that thing. And we're back to 29 over here, which is clearly wrong because we should be able to get through here in 18. Hmm. There's another thing we can do here too, which is we can bail out once we've already gone too many steps, which will make it faster. And then goes to 24, which, you know, nobody knows what the heck that's all about. Guess you need to be long. We're going to break some stuff here, right? Okay. Clear ground as a dot. Otherwise, blizzards are drawn with an arrow indicating their direction. The map includes 2 blizzards, one moving right, one moving down. Conservation of blizzard energy. As a blizzard reaches the wall of the valley, a new blizzard forms on the opposite side of the valley, moving in the same direction. After another minute at the bottom, right. So we went from here to here and here. And we go to here, which is a 2. Sure, and then they split up again. Repeats at least as long as you're observing it, but it probably forever. Here's the more complex example. Your expedition needs to move. Begins in the only non-wall position top row, needs to move the only non-wall position to bottom row. To each minute, on each minute you can move up, down, left, or right, or you can wait in place. Even if blizzards act simultaneously and you cannot share a position with the blizzard, in the above example, fastest goal is 18 steps. We already know that after step 1, we have to end up here, right? So I'm kind of curious. I guess we're going to have a print. fine. Okay, what did I miss here? That is very much not what I expected. Missed all the dots. That looks wrong. Because of that. Okay. So that's the first move. That's a potential move. That's another potential move. That's our merge, right? That's a move, and then that's a move. Okay. So now what I want to do is let's not print one out every time. Let's just print one out every time we think we have a better one. So there's 46, gets us out. That dot is in the wrong place, isn't it? No, it's in the right place. We get out after 44, and then that's it. There's no possible way that those are all the best choices. There's no way it takes 46 steps with only 2 blizzards. No way. All right, 46, 44, that's it. All right, there's no way that this doesn't go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like, there's no way this doesn't go 10. So, what is happening? Are we getting, or is our cache wrong? That list doesn't look that substantial. All right, this is kind of what I expect because oh, it's so weird. We're going to duplicate it 3 steps, 3 steps, 2 steps, 2 steps. just $29 and $24. How many steps? You say I can get out of here in 18 steps. I don't think I've implemented any of the logic incorrectly. So equality is parties equal to other party, which we're basically 100% sure is console right line 1, 2 equal to 1, 2. And then okay, so that part's the same. And your hash codes are equal. Right. Blizzard select many gives me back I enumerable of int and direction as a hash set. It would be impossible for two things to have the same location and direction because nobody ever changes rows. So that's okay. Plus, I would expect the two hash set to yell at us if that wasn't the case anyway. What was the other day we were doing get hash code? What did we do? We didn't even do I equatable. We just did equals. We just did equals. Maybe that's the problem. Is that the problem? Nope. All right, all we did was get hash code and equals. Every blizzard is in the other blizzard. We have the same count of blizzards, and every blizzard is in the other blizzard. Seems correct. We are caching things, we know that for sure. Okay. The parties at the end, we're good. If we're outside the bounds, we're bad. X is less than min x. X is greater than max x. Y is less than min y. Y is greater than max y. Those are ors. If the party is in a blizzard, that doesn't work either. Otherwise, the step, the party, and the new blizzards get thrown up in there. Already had some naming collisions. Visited and evaluated. Make a movement cache out of it. So if you're going left, new location, we wrapped. We saw that stuff doing its thing, at least for down and right. So if you go left, go off the edge, you go back to the right. If you go off the bottom, you go back to the top. If you go off the right, you go back to the left. If you go off the top, you go back to the bottom. X, 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 Y, 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 X, 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 Y, 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 Y. You get put back into the new blizzard lists. I kind of want to print the board here. Because I want to see if we can see the winning board in here, but with the wrong number. Which really doesn't make any sense, but whatever. So one thing I'm wondering is, everything that I push, all right, so everything I push is one step further. I wonder if I should not use a stack. I wonder if I should use a doubly linked list. And always pull from the front. Right? Add last. Remove first. Let's see, to run first, right? And then we do to run remove first. Is the problem that I'm like skipping because of the cache? Current. First value. All right. Yeah, maybe I'm not running something because the cache tells me not to, but then I end up pulling the worse version because the cache told me not to. 18 steps. Yeah. Okay. Let's go get the real data. Printing these boards might be dumb. We'll see. You say you never finish, which I don't like. Definitely don't like. Why? Oh, you know what? I can stay still here. Oh, you son of a bitch. I can stay still here because this one is going to rotate through here. So you can always stay still. Oops, that's supposed to be end. Okay, let's bring you over here. See how bad you are. Oh, you're taking a core. And RAM usage is growing. Okay. I'm curious. We still have this. Let's do this for 1,000. Let's see how often 1,000 hits. Okay, so every time we hit 1,000, like we're not eliminating anything in the cache, which I guess is possible because we're now going from the front instead of from the back, right? Seems pretty slow though. Why? I mean, we're making a lot of stuff for sure. We're making a lot of stuff. Is the problem the conversion to the hash table here? Should I be using it? Instead of trying to do a contains key, I should just do an any search. Problem is that's linear. And that means searching basically 3,600-ish. 3,600 might not be too bad. Like if I don't even try and do the cache thing, well, we'll get through them a lot faster, that's for sure. I wonder, I mean, that's still, I'm not going to call that fast. So there really is only like pop from the top. Hmm. Does it still work with the old data without the cache? Does. We end up doing 10,000 searches, right? Right line, total searches is, what was it called? Evaluated. No, we leave that there. So we got 11,000 searches without the cache. If we bring the cache back, we had 74 searches, right? So that makes a lot more sense. Can't do this without the cache, that's for sure. This one, by the way, should be really small. Skipped 11 because it's worse than 10. Why would that be a trigger? That shouldn't be a trigger. Yeah, why? That's weird. We say we skipped. Oh yeah, we don't. Yeah, there's no way that's correct. That's why, because the prints are wrong. I copy pasted everybody. Like a dumb bee. Skipped 11 because it's worse than 10. Probably shouldn't have even evaluated it because of 11, right? This should have said don't even bother. Cut a couple searches out, right? '67. Now I need to go get my data again because I lost my data. think I'm printing every 10K. Yeah. Hmm. There's probably a cache that I'm missing. But I don't know what it is. I think maybe what's happening is we end up queuing things that we don't care about into the cache because we don't know that it wouldn't be good until later. No, I'm still kind of surprised that after 70,000 moves, we still don't have any cache hits. All right, well, I'm gonna let this run, I guess. I'll take a quick bio break and be right back. All right, well, I got an answer while I was gone. 3 minutes and 15 seconds, 249. Let's see if that's right. Okay, it's right, but what it means is I'm definitely missing some kind of caching. forgot his snacks in the entrance to the valley. Since you're so good at dodging blizzards, he'll humbly request you go back for his snacks. From the same initial conditions, how quickly can you make it from the start to the goal, then back to the start, then back to the goal? In the above example, the first trip. 18, 23, and then 13 for a total of 54 minutes. My guess is my algorithm is fine. It just means that I'm going to have to do I still have it running? Yeah. So isn't that interesting? Like we never had any cache hits until we hit 249 steps. Like literally no cache hits, and then we got through at 249 steps. But I wonder if I don't need the cache anymore. All right, let's remove the cache and just let these go here. Skipped 18 because it's worse than 18. 8,684. We got 18, which was the right answer. We can right, you need to be able to get one better. Skipping 18 because it's worse than 18 doesn't help us, right? 5,474. Cuts it down. I'm wondering what happens if I put the real data back in here, if that's enough. Because we got our answer after, what, about 13, 14,000? I don't remember how many it was. We should always be evaluating the best possible answer. That was like 100,000. Something like 100 and something thousand. Because I just changed this to every 10,000 instead of, or every 1,000 instead of every 10,000. And it was 3 minutes and 14 seconds last time. So let's see what happens here. Because if I'm going to have to run the algorithm 3 times, it should be faster than 3 minutes and 14 seconds. That's really all I care about, right? Curious what's going on with memory here. Can't tell if that's Because we're not garbage collecting because we don't have memory pressure yet, or what? Yeah, this isn't working. Okay. So we still need the cache. Interestingly, though, I feel like wait. What if I pass the cache into the mover and don't even push it? That'll definitely save us something, right? So hash set of movement cache. All right. Then the proposal is the new party and the new blizzards, right? And if that's already in the cache, it's not in the cache, and we'll add it and push it. And now we don't do this anymore, right? I mean, this could also go up there. I don't know. It might be helpful. Might be the wrong place though. No, that would be the right place because by using the linked list, we know we're going in order of best chances. Yeah, we're definitely going in order of best chances. All right, let's make sure this still runs here. Gives us 18 with 62 searches, which I think is pretty darn low. 10 with 104 searches. So I kind of don't want to run this again exactly like this. I want a part one best to come out of this, right? That's not what I wanted. Actually, this has to be, so your step a party in blizzards. Step a party in blizzards, right? So your current step plus 1. And this, right? We don't need these skip prints anymore. We're always done as soon as we find one. This notion of the best or the best board actually doesn't matter, right? Don't think anyway. Let's not do this. Let's actually do this though. We're going to return that out of part 1, right? It's always the first one we find. Yeah, return that. Right? Oh shit, I can't do this, can I? No, I can't. Damn it. Can, however, just return current step plus 1. You can be long. Problem is I need to run yeah. Boy, this is going to be an explosion. I can just tell. 18. Was it before 10, right? 10. You're just going to take a long time. Yeah. Um, So here's the problem with all of this, which is what I need is targets. All right, so part of the problem is I was thinking that I could just take the solution that gave me 249 and that would be good enough. But the reality is I can't, because there might be multiple 249s, and 249 might not necessarily be the best way there and back in total, even though the sample data suggests it is, because it's still 18. But I can't just take the first 18. I know I have several 18s, and they all have different blizzard patterns, which means they could all be better. And it could be possible that, I mean, even though in this case it's not, it could be possible that a 19 could get me back quicker, and back to the beginning and then back to the end quicker again. So I think what we need then is maybe a list of targets. A stack of targets. And what we need here then is if new party is equal to target's peak, right, then target's pop, and return target's count is 0. No, if target's count is 0, return true. And then here, the targets push the end, right? And then when I come down here, the targets, we're going to do push the end and then the start, and then the end again. And then here we have targets. And here we'll have targets. And if we go all the way back here, this is probably going to be 30-ish, right? 10 out, 10 back, 10 return. Okay, that's no good. Oh, we can't just, oh shit, we can't just pop out of targets. Targets has to be part of what we're storing. So the cache, or the to run, has to have the targets in there as well, which is a stack of int x, int y targets, which I think means the targets list also needs to be part of the movement cache. I don't know how this is actually going to finish in time. Sorry, 2 stack. have to be a stack. It can be an array, which is fine. These are length, of course, and not count. Actually, the length is fine. We don't actually have to check the values because the length is fine. Okay. All right. You need to have stack of this, targets. Ten and 20. 20 doesn't sound right. Okay, so we've moved 10. Targets should now contain 1, 0, and 5, 6. The new targets should do that, right? So the new targets contains 1, 0, and 5, 6. So we overwrite the new targets. That looks correct. Is that right? Because we got to move towards the new target. So here our targets list is 1, 0, and 5, 6, and the new party is at 1, 0, and the step is at 16. I guess I got back faster than 10. And then here the step is 20, and then I got back and I'm done. Okay. 18 and 21, no way. 54. No way. So there's 18. There's 18, but with 3 targets. What feels weird about this is having this logic here, I'm not sure works anymore. What I really want is I really want you to get pushed. You want is a priority queue. That's the first problem, right? Then I want the priority queue. Yeah. This linked list isn't right either. All right, let's forget part 2 for a minute. Is there a priority queue in .NET now? Oh, good. I love it. So we have an element and a priority. Let's say string and int. Okay. PQ add. NQ. Gives me a string. DQ gives me back just the string. So the element. Right, okay. So then instead of a linked list, it's this as the thing in the queue, and then a long for its priority. We're going to NQ this with priority 0. Right. You get that back. Then we're going to pull it out and we're going to say if current targets count is 1 and right? Current targets count as 1, and current targets sub 0 is equal to current party targets by your stack. Okay. And current targets pop. All right. Don't think I'm going to need a cache. Once again, I think I can get away without a cache here by using a priority queue. Okay, so if this is this, and then if current targets count is now 0, then we're going to return current step. Okay, we're also going to say, which means I don't think I need best. I don't think I need the visited queue. I don't think I need that. I am curious about this, just from a timing perspective. So we move the blizzards, and then we say if let's see, if try get legal move from current step +1, current party, new blizzards, that'll give us a legal move, and then we can put that into to-run enqueue legal move dot step. Okay. So then we've got that, and then we've got 1, 2, 3, 4. And actually, let's make 1 and then copy the 3 because this is going to be current party X +1, current party Y. Because the move is a step and a party and blizzards and a stack of targets. And a stack of targets. So you're going to need the targets. Legal move. Right. Right. You're going to be the legal move left. Through X -1. You're going to be the legal move up. So you'll be Y -1. Move up. Legal move up. Legal move up. Legal move down. Y +1. Okay. Out object. Oh, you tried. All right, so you're the step, you're the party, you're the blizzards, you're the targets, and then you are this is what a legal move looks like. So step, party, blizzards, targets, legal move. Let's see. Return false, which is fine. All searches will go here. So no best, no visited, none of that. Okay, we're going to move you up top. Because you're going to be a lot like this. So legal's false. Parties in the start or parties in the end, then that is legal. Otherwise, legal is so do this. All right. Your party, not new party. Blizzards contains the party, and legal is false. Otherwise, let's do this. Return true? No. Legal is true. If legal is true, then legal move is step, party, blizzards, targets, turn legal. Okay, what's your problem? I guess that can always be this. If that's always this, then I can just do this. Turn true. Turn false. Turn false. Lastly, you're true. Yeah, I didn't mean to totally do that. I guess I did. That, well, I was evaluating quite fast, but Okay, so this should be so we're at 1-0, which is fine. We've got 19 blizzards, which is fine. Actually, let's do this even easier, right? Let's do this like this. Right, we're clearly evaluating way too much stuff here. So let's stop there. Okay, so current is the starting board with one target of the end. No problem there. We're going to make our two blizzards. One to the right. One down. Staying in place because there's no blizzard. Here is fine. 2 rundown has a count of 1. These are supposed to be down. Okay then. And if we're always going to do that, did it really take 80,000 searches to get there? Really? 9,000 searches to get there. But no cache. I don't know if it was 19,000 before. I don't know. Let's see if we get the right answer for our puzzle input. See if this is faster. Oh, you know what? I bet the Q is backwards. It's an array quaternary min heap. Each element is in cube. The associated priority determines the elements of the lowest priority. Oh, no, that's right. The lowest priority get dequeued first. Yeah, okay. Never mind. It's the lowest priority get dequeued first. Still really surprised that sample data took 9,000 iterations. The visited list may still be useful as a cache. How are we doing on memory? Yes, this is what I was worried about. Still exploding memory. My guess is the cache is helping with memory more than it is the computation time of anything else, right? Yeah, that's no good. So I still need the cache. Still need the visited cache. Hmm. Let's do this. So it is potentially illegal, but we need to make the movement cache first, right? So the cache item is a new movement cache of the party and the blizzards and the targets. If visited contains the cache item, only if you haven't visited it before, we put you in the cache and queue you up. 73 searches instead of 9,000 seems better. Call me crazy. Back to being slow again. I had to write equality, right? Maybe I should keep it as a dictionary. I wonder if that's part of the problem. That conversion from dictionary to a hash set. Memory's still growing, but growing slower, I think. I keep thinking about this triple target version where we have to run this in 3 directions. Whether or not we're going to be able to afford to do that from a memory perspective. I think I'm about to give up. There's definitely a cache to be done here that I don't know what it is yet. And we're still exploding on memory. $249 after 130,000 searches. You know what I didn't look at was the time, but it was definitely minutes. So I haven't really done anything to make this better. I think I can extract all this and all I need is 2 run. I shouldn't be using targets here. I should be using a copy of targets anyway. This is a new location. Why are you upset about new location? Oh, just because you don't know what 2run is yet. I call this find path. Okay, let's see if part 2 works correctly. Because we should be able to do this like this. Say 23, that's a lie. Don't need to run part 1 for right now. I would like to see what happens here when we pop the target. Okay. Sorry about that. So we should be on step 18, right? Current. Right, we're on step 18. We're at 6.5, which is where we're supposed to be. New targets, so everybody's got new targets. So the current targets are 651065. So those are now 10 and then 65. Okay, so the new targets are 10 and 65. So when I come in here, the targets are 10 and 65. Standing still is always a possibility. I think the visited cache needs to get reset. Because I'm trying to walk back now, right? I need an array of hash sets. That is the size of the targets. Yeah, I can't do that, can I? Fine. If, let's see, visited, this is going to be visited by target size. Not visited by target size, try get value of key is going to be current targets count, out var visited, visited is new, and visited by target size of current targets count is equal to the visited list. Say 23, which I don't buy. Actually, this needs to be down here, and needs to be new targets. Still don't believe 23 though. Because there's no way you can walk all the way back. You can't, there's not enough time. So there's our new targets. Our visited by target size is 3 with a count of 80, so we need to go make a new one. Our new target count is this. Current is on step 18, a party of 6-5 with 15 blizzards. This 2 run has 7 items in it at the moment. Okay. You can always stay put. So that puts our 19 with 6-5. Print the board. Yeah, let's actually do the new blizzards. How did you get up there in 19 steps? Let's do it with a simpler board. One, two, three, four, five, six. Like you can't get there in 16 steps. Targets are different. Hmm. Yeah, I don't know what I'm doing wrong. And it is currently almost midnight. So I think I'm gonna call this. See if something comes to me. So sorry that I couldn't get part 2 done today. I guess that's kind of the way it goes. So I just gotta hope tomorrow's not terrible, and sometime between now and 9 p.m. Pacific tomorrow, I can figure out what I have done wrong here. I feel like it is really a ridiculously complicated code, and I must be missing a simpler way to do it. But it's also day 24, so maybe that's not the case at all. Maybe not missing a simpler way to do it. There just isn't a simpler way to do it, which never the case, but whatever. I'm sure there are people who finish this in 14 minutes, but that was not me today. Oh well, I guess I'll see you all tomorrow.